Good morning, guys. Today we're going to finish 6.1, which is talking about real-life applications of exponential growth and exponential decay. Now, when do we see exponential growth and exponential decay? A couple of places, actually. And I want to differentiate into two big groups. Just a regular growth and decay model and compound interest, which is what we see in banks. Now, a growth or decay model is pretty straightforward. It's like, say I bought a car for $10,000 and it depreciates or loses value at a rate of 3% every year. That would be an exponential decay model. So you know how much you'd lose every year, and after, 6 years, you know more or less what the car is worth. An exponential growth model is just when something increases. For example, you have 5,000 rabbits in a rabbit farm and they grow at a rate of 25% every year. How many rabbits will I have if I begin with 500 rabbits after 7 years? That would be an exponential growth model. Now note that these growth rates are on a per year basis and they are only applied once every year. This is different from compound interest that we see in banks. For example, banks say we're going to apply a 3% growth every month for 12 years. Now, you know that it is applied multiple times per year. So, in essence, when you see the word compounded this many times or compounded this many, monthly, yearly, it's compound interest rate. When you see the word compounded, it's compound interest rate. When they give you just a flat rate, they grow 7% per year, you can just use a regular growth or decay model. Now let's go over examples of each one and the formulas for each one. Let's begin with exponential growth. If you see page 297 in the books, you have, for exponential growth, you have these values. That's growth. And for decay, you have a very similar formula. Let me explain what each thing is. Now, this is what you're going to end up with after the population or value grows or goes down. Whenever you add the R, let's go over each letter. This is going to be the answer, or what you're left with after time passes. A is what you begin with. If the car is worth $10,000, that's where you're beginning. If you begin with 500 rabbits, that's where you're beginning. It's always going to be a 1. And then R is the rate of growth, but expressed in decimal form. Normally, they're going to tell you, for example, you have a growth rate of 25%. Here, it's expressed as a percentage. You cannot put that in here or it's going to be incredibly incorrect. You have to turn the percentage into a decimal. How do you do that? Divide by 100. All you got to do is run the decimal spot 2 places. So even though I grow at 25%, my R would be 0.25. In growth, you add the growth rate expressed in decimal form. In decay, or when you lose value, when you lose things, when things die, or etc., you subtract the rate from 1. And T is how many years that happens for. Let's say, for example, I begin with 300 rabbits. They grow at a rate of 30%. And I want to know how much I end up at after 8 years. You're going to use, since it's growth, because they're growing, you use the top one. So I don't know what Y is because that's what the answer I'm going to get. I began with 300 rabbits. 1. Let me actually just rewrite it here in a more organized fashion. 300 rabbits. 1 plus, because we're growing, 30% expressed in decimal form. You divide by 100. 0.3 elevated to the 8th power because it's 8th year. Now remember PEMDAS. Some students end up with billions and billions of rabbits after 8 years. And if that's the case, that student could solve the world's food problem. But at that time, we'd probably have a rabbit problem. Remember, PEMDAS. You add these two first, parentheses, exponent, and then multiply by 300. If you multiply this times this and then raise that to the 8th power, rabbits would rule the world. So again, we don't want rabbits ruling the world. Pandas, add, exponentiate, and then multiply. That's going to give you how many rabbits. Now let's say instead of growing, so again, just to rewrite this, you'd have 300 to the 1.3 to the 8th power. Elevate and then multiply. Now let's say instead of growing, you have 500 rabbits, and there is a disease in your rabbit farm that's killing off 7% of the rabbits every year. It's killing off 7%, poor rabbits. So again, I want to know how many rabbits I'm going to have after 8 years, because this disease is killing 7% of the rabbits every year, assuming, they don't grow. But that's another subject. Just let's assume they don't reproduce. So you're going to begin with 500, 1 minus 7% expressed in decimal form minus 0.07 elevated to the 8 years. When you rewrite this, you're going to end up with 0.93 to the 8th power. And that's pretty much growth or decay models. Not compound, just regular growth or decay. Pretty straightforward. Remember, if you don't see the word compounded, it's just use the regular growth or decay models. Very simple, very straightforward. Now, let's go over compound interest rates, which actually, if we're going to do a project for the 4th quarter, I was trying to do a PBL. I'm not sure how that's going to end up with the 4th quarter with the whole companies and compound interest, etc., etc. But it's very important just so you can know how banks work. And if we don't do it this year, I'm going to heavily focus it on next year because it's a very useful subject. You can just look at 2 credit cards or 2 banks and see where you're going to end up with more money after 1 minute and a calculator. So knowing compound interest rate will actually help your wallet, and it's good. So you better know how to work compound interest rate. The formula is very similar to the growth or decay models with a few modifications. Let me write the compound interest rate formula now. And I'm going to explain a couple of things. So there's a couple of things that are similar. We have this value here, which represents our initial value. I'm going to talk about that in a little bit. We have the 1 here, we have plus, and we have time. Pretty much the only thing we did was add an n here and an n down here under my r. Just like in growth or decay models, the r here is also the percentage expressed in decimal form. You have to divide it by 100. Now, A is the amount of money, hopefully it's going to be a lot, the amount of money you're going to end up with after the interest rate is applied in a compound fashion after so many years. So that's going to be the end result of applying the interest. P is principal. It's what you begin with. You deposit $5,000. That's where you're beginning. That's the P. It's always going to be 1 here. It's always going to be plus here. Again, if somehow they're taking money away from your bank account, you just put a negative here. If they're subtracting money. But let's just say this is compound interest rate. The R is the same here, and the T is the same here. N, which is the only new addition, is how many times that interest is applied per year. Now, there's a couple of ways you can see questions related to compound interest. You can have like direct questions saying, the interest rate or the rates are compounded 4 times a year. You know that your N, which is repeated, you're going to have 4 here and 4 here. So they can use actual numbers to represent N. Oh yeah, it's going to be applied 10 times a year. 10 here, 10 here, you're done. However, there are other ways to express the N. If they tell you it's applied monthly, you have to know that there are 12 months in a year. So N would be 12. If it's applied quarterly, there are 4 quarters in a year, so n would be 4. If it's applied weekly, well, you can say, 4 weeks times 12 months, even though, depending on where the years begin and end and where the week ends or begins, it might be a little off, but you can just, confidently say n is going to be more or less 48. 12 months, 4 weeks per month. Now, the only confusing thing here is the word bi-weekly, bi-monthly, bi-yearly. I always ask this question in class, and the exact same thing always happens. I ask students, does bi-weekly mean twice a week or every 2 weeks? Half the class says twice a week, half the class says every 2 weeks. Bi-monthly, what does that mean? Half the class, more or less, says twice a month. The other half says once every 2 months. And they are both half correct. The terms, when you look at the actual definition online or, old school Webster's dictionary, bi-weekly can mean both twice a week or once every 2 weeks. So every time you see bi-weekly, bi-monthly, bi-yearly, you should ask the question, do you mean once every 2 years or twice a year? If you sign up for a job and they tell you, bi-yearly you get, 2 weeks of vacation. Oh my God, that's awesome. Yeah, but we actually meant once every 2 years. And, you already signed the contract, you agreed to. So, of course, I don't think people are going to be that mean, but whenever you see bi-weekly, bi-monthly, bi-yearly, you have to ask, and please be more specific. Does that mean once every 2 weeks or twice a week? Because it makes a huge difference. If I were to tell you, yeah, we're gonna have exams bi-weekly, having 2 exams a week or having 1 exam every 2 weeks, it's quite different. So just make sure every time you see bi-weekly, bi-yearly, blah, 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 make sure you ask and you specify twice per time unit or, 2 times, twice per time unit or once every 2 time units. You have to be very specific. Don't get tricked or fooled in real life. Now let's go over an example. Let's say a bank offers a 5% growth compounded bi-monthly, and you begin with $500. $500. You want to know how much money you're going to have after 3 years. Bueno, you go to 2 banks. They both say bi-monthly. They both give you the exact same thing. In one bank, you ask, does bi-monthly mean once every 2 months or twice a month? And that bank goes, yeah, it's twice a month. The other bank says, no, it's once every 2 months. I want you to calculate how different each scenario will be, but I will give you the formula. The first bank, again, we begin with $500 principal, 1 plus my rate expressed in decimal form. You divide 5 by 100, you end up with this. Now, this bank told me it was twice a month. Bi-monthly here meant twice a month. There are 12 months in a year, so my N would be 24. And here I would have the exact same N, 24, times 3 years. The other bank said, no, it's once every 2 months. So I have the exact same growth rate, but here I'm only going to have 6. Because since it's once every 2 months and there are 12 months in a year, it's going to be 6. Now, some students will say, Profe, but when we divide this by this, it's going to be a way smaller number than when we divide this by this. How do I end up with more money? Simple, because the exponent here is going to be way bigger. So for homework, I want you to calculate these 2 scenarios. I'm going to give you a couple more exercises now. But one thing to keep in mind, in a calculator, this is tricky. I do not recommend you plug this entire formula in and hit enter. Please do not do it that way. You're probably going to do it wrong. Believe me, you have to include a whole bunch of parentheses and it's just uncomfortable. What would I do? I would begin with this division. You literally divide 0.05 by 24. You just divide that. Don't plug in the entire formula. You divide this, then your answer, you add 1 to that answer, then you write it down, you write the result down, whatever, you get this. Then on the other, aside, you clear everything, you multiply this by this, that's gonna give me 72. And then you're gonna write the previous answer that you wrote down and you raise it. You don't multiply, I'm sorry. You raise it to the exponent of 72. You hit enter. That's gonna give you a number. And when you have that number, you just multiply that number by 500. Please do it in that order and you'll get the proper response. If you know how to manipulate the calculator properly, you can use all the parentheses, etc., etc. But even though, I still do not recommend you do it that way. It's even faster the way I'm telling you. Just divide, add, write that number down, multiply the exponents. That gives you a number. You elevate the answer you wrote down by the number you just got. Hit enter. It's going to give you a number. And that number gets multiplied by the principal. That's going to give you the amount you have at the end. Now, please, again, the same thing that happens in exponential growth or decay. If you divide this, add this, and multiply this, you're going to end up as a multi-billionaire in 2 weeks. Oh my God, that's an awesome bank. Please do not do it all the time during a test. Profe, pero I got $5 billion after 2 weeks. I would like the name of that bank because it's probably not doing its math correctly. Divide, add, exponentiate, multiply. Done. That's it. Now, for homework, remember, I want the answers to these two scenarios, and you'll see how different, how much, and again, you'll say, oh, but I only ended up with $3 more. That's because you only began with $500. Once you start making money, you deposit $10,000, $20,000, $50,000, that starts adding up, and you end up with a lot more. That might mean an extra trip to New York or something every year. So it's very useful to know the small changes in interest rates. And the good thing about this subject is, people, everybody uses banks. You're going to be using banks. You might work in a bank. My wife works in a bank. Trust me, she uses this all the time. When you're going to calculate bonos, inversiones, préstamos, you use this every time. Investments, certificates, loans. It's very useful. It's very simple. You don't have to, just adding, subtracting, multiplying, and raising to a powers. And a calculator. Do not do this by hand, guys. Do not do this by hand. Calculator. You're going to end up, in a couple of minutes, which bank would be better for you. Now, in this case, it's quite clear because you're just saying, well, obviously, I'm going to take the bank which compounds my interest at a greater fashion. But let's say they give you this example. You got a bank that gives you a 3% growth rate compounded 5 times per year. And you got another bank that gives you 4% growth rate. But this one's only compounded 4 times a year. In this case, the interest rate is smaller, but it's compounded more often. In this case, the interest rate is larger, but it is compounded less often. How does that change? Which bank would you use? Now it's not as simple as the other one, which was pretty straightforward. If you were to calculate this case, and this is pretty much how the problems will be in tests, like which bank would you use, how much money would you end up at the end. Now you can't just see it and say, oh, obviously this one's better. I actually don't know. I would guess, depending on the amount of years. After you go over, I really don't know. I have to do it. I just have to do it. For homework, please do the following. Please do. Question number 30. Besides the 2 examples that I gave you guys, besides the 2 examples of the 2 banks, please do number 37. Please do number 39. And please do number 40. Now note, I'm going to give you a couple of tips. 37 is compound interest rate because it tells you they're compound. Number 38, even though it's deposited in a bank, it's not compounded X amount of times per year. So it's the basic growth model. So you're going to do 37, 37, 39, and 40. 37 is with the compound interest rate formula because it says in the problem it's compounded. 39, it's pretty much the growth, the decay, the exponential decay model, because it's not telling you it's compounded X amount of times per year. And number 40, it's the growth model, because it does not tell you it's compounded X times per year. Even though it's interest and banks, if the word compounded is not there, you do not use the compound formula, okay? Because if you think about this, if they tell you that it's compounded yearly, that means your N is gonna be 1, because it's compounded 1 time per year. And if this is 1, what is R divided by 1? And what is what is R divided by 1? It's gonna be R. And what is T times 1? It's gonna be T. And if you change it, you're pretty much gonna end up with the exact same formula for growth rate, for growth or decay when your N is 1. So if it's compounded, compound formula. If it doesn't say compounded, use regular growth or decay. So again, exercises 37, 39, 40. When they tell you, please give me the model, that's pretty much writing the formula and plugging the numbers that you have. Pretty simple, straightforward. 37, 39, 40 homework and the 2 problems I put on the board. That's pretty much it for today. Have a great day and I'll see you all tomorrow.